are you? My name is Anna Tenbenzel. Welcome back to my channel. I am really powering through these LeetCode problems because I do want to get the first 50 done sooner rather than later. So I am on the LeetCode problem number 34, and the solution is in Python. So I want to go ahead and jump right in. This is another medium. So if you've seen the last couple videos, they've been hard, and now medium. And all I want is a little bit of a break. I want an easy one, but this is what I'm here for, is to improve and learn something new every day. So I'll reset the timer from my last video and we will get started. So I did read this question twice, and yeah, so we'll read it one more time and then we'll jump right in. So number 34 is find first and last position of element in sorted array. So given an array of integers nums sorted in non-descending order, find the starting and ending position of a given target value. If target is not found in the array, return -1, -1. You must write an algorithm with an O log n runtime complexity. And then they give you these examples here and these constraints. So I think for this, I think a binary search function is probably going to be our best case scenario. But I'm not sure. I do want to find each side of this, I think, to basically determine whether the first occurrence or the last occurrence, whether to search for the first or last occurrence of that target value. But I want to try to keep it down into a single binary search. So how to do that? I think I need to have a function. But I don't, maybe find bound, because I've done something similar like this. So I'm going to say def find bound, and I can always change this later. Num's target is first. Frist? The other thing is I could do 2 binary searches, but if I'm thinking about like just overall fewer iterations, that would super help runtime on this. So I'm going to try it with the 1, but I do think I might need 2 binary searches to make this work. So let's say left, right equals 0, length, nums. So while left is less than right, this is kind of the same vibe as the last one, where we're trying to find that target or that pivot point. So I'm kind of reusing some of that same logic here. The last 2 have been very similar. So I think I should do if is first and nums mid, because we're going to find that midpoint. Is less, there's greater than or equal to the target. But then we need to say also, okay, we also need to do the opposite. So if it's not, so I'm going to say if is first and nums mid is greater than or equal to the target, or this might not work, I'm not sure. Not is first and nums, or what did I say, nums mid is greater than the target. Then we have right equal to mid. else left is equal to mid plus 1. And then we'll just return left, right? I think that makes sense. So let's say left index equals find bound. Nums target and true. I need that to be IDX. So if left IDX equals the length of nums or nums left IDX to the target, then I want to return -1, -1. And then I just want to say that for the right, it will return false. For right IDX find bound of nums target and false is 1. And then we'll return left IDX right IDX. Yeah. So this is just using a single search. And I could break this up into 2, but let's run it with the 1 and see what happens. Left IDX if first off, I have an extra space in there. If could not find target false because I have a spelling error. That's why you couldn't find it. Okay. Okay. So I guess you don't need, well, I'm not going to say that yet. I guess you don't need 2 binary searches. Yeah. Let's submit this cuz it's for some like the larger What? There's no way. 97 and 99? Holy moly, yo. Holy guacamole. That's what I get for trying to be more considerate of runtime. Okay, that's not bad for 7 minutes. I don't feel like that was medium. I think it was pretty clear that you should do a binary approach here from my perspective, but I think if I would have done the 2 binary search functions, I think I would have not hit this for runtime. So I'm actually super excited. There's no way. 99% and 97%. I'm beating 99 and 97% of users for runtime and memory. That's so wild. That's so wild. I need to start thinking more critically about these things anyway, because that's like been my goal with this whole LeetCode journey, is to not just code, but like get better at optimization and memory and runtime, because it forces you to think about that. So I'm glad that me taking a minute to really think through that, and also being unsure, because like I don't have the same confidence as like people who've been doing this for eons, but I am getting more confident with Python as a whole in terms of like complexity, right? And that's like what I want to improve on with all of my coding languages is like improve on the professionalism of it. So I'm glad that this did pretty well for, like 24 lines of code or whatever it is. Yeah, so I'm going to leave this in the GitHub repo of my LeetCode solutions. You guys are more than welcome to fork and clone it. It is in the video description down below. Make it better, make it worse, have some fun. If you can make it better, I would be so impressed. Like, I cannot tell you. Please try. I dare you. I should be doing giveaways for like people who can make my codes that are like over 90% any better. Because you guys deserve more than a cookie. Okay? Like that's tough stuff. That's tough stuff. Anyway, make it better, make it worse, learn something new, have some fun, and I will see you guys in the next video. Thank you guys so much for watching. Goodbye.